We're graphing systems of equations. A system of equations is nothing more than a set of two or more equations. So we've been dealing with one equation, now we're going to deal with two equations. Now, one way that you can solve for these equations is to graph both equations on a coordinate plane, and wherever they intersect is the solution. Of course, in order to do that, we need to solve for both x and y for both of these equations. So let's go ahead and start. For y equals 3 plus x, I chose to go with -2, -1, and 0 for my x coordinates. Those are going to give me some fairly small numbers. Keeping it small, I don't have to worry about my graph being extremely large or running out of space if I started with a smaller graph. With the other equation, I chose -1, 0, and 1. Again, keeping those numbers kind of small. I could have went with -2 and that would have kept it even smaller. -2, -1, and 0, but personal choice. Alright, here's my coordinate plane. I've graphed the 3 points here from up here, so -2, 1, 1, -1, 2, and 0, 3 is represented there. And I've just created a straight line. Now, very important here, use a straight edge or a ruler, a straight side of a protractor. It's really important that you have a straight edge when you're doing these lines, and you'll see why in just a minute. Okay, here are the 3 points here graphed on the coordinate plane. And you'll notice that this new line, this for the equation, intersects the initial equation right here. The point where they intersect is the solution for the set of equations. And that solution for this set is -2, 1. Now, if you didn't use a straight edge, it's real easy to make a wobbly line, and then you really can't tell where exactly the two lines intersect. So again, very, very important that you use a straight edge. Or I'll show you an alternative. Now, the book will have you graphing the two equations in order to find the solution. However, you really don't need to do that. We've got two equations here, and both of these equations equal y. In other words, they both equal each other. So by getting rid of the y's and making the two equations equal one another, we just need to solve for x. I've used the commutative property here to flip my equation. First, I'm going to subtract x from both sides. I'm left with 3 equals x plus 5. So now I'll subtract 5 from both sides. And I'm left with -2 equals x, or x equals -2. At this point, I'm just going to take my value for -2, replace it for this x. I could do it for this x, doesn't really matter. And y equals 1. So without graphing a thing, I've come up with the solution here, which is the same solution I came up with when I graphed, -2, 1. Let's look at a slightly different example now. Here, x and y are both on the same side of the equation. What I need to do is get y by itself. For this equation here, I'll do that by subtracting x from both sides. And that will give me y equals 7 minus x. For the equation on the right, I'm going to add y to both sides. Here I have 3x equals y plus 5. Subtract 5 from both sides. And my newly written equation is 3x minus 5 equals y. Notice with the equation on the left, I subtracted x, and the equation on the right, I added y. Each equation is going to be slightly different, and how you approach it is going to vary. I could have easily subtracted 3x from both sides. but it really doesn't save me any steps by doing that. Without actually graphing, I can make these two equations equal to one another. I'll go ahead and add x to both sides. Simplified, I have 7 equals 4x minus 5. Go ahead and add 5 to both sides. And I have 12 equals 4x, so I'll need to divide both sides by 4. And x will equal 3. I need to find my y, so I'm going to replace x up here with the value of 3. I could easily do this with either equation. It's just with this equation here, it's far simpler, fewer steps involved than dealing with this one here. So by replacing 3, I get 4. Therefore, the solution will be 3, 4. I could easily graph both of these equations separately and look for an intersecting line, but I would ultimately get the same answer. So when doing this, two things to remember. If you are in graphing, make sure you use a straight edge or a ruler or something that's going to give you a nice straight line. Do not hand sketch. And if both variables are together, get the y by itself. That's pretty much standard procedure.